Consider question 7. It says two vertical cylindrical vessels containing water are connected by a thin horizontal tube at their bottom. Water in vessels is enclosed by pistons P and Q of masses m and alpha m that stay in equilibrium in the same level. A gradually increasing downward force is applied on the piston P. When the magnitude of this force becomes capital F, the piston Q moves a height h above its initial level. Now the force on the piston P is gradually removed and applied on the piston Q. How high will the piston P move above its initial equilibrium level when the magnitude of the force on the piston Q becomes beta times F? We need to neglect all dissipative effects. So let's consider this picture, and this piston is P, this piston is Q, and there's a liquid filled. Let's say cross section of this is S1, the cross section of this is S2. Initially, as the question says, they are staying at equilibrium. Then if we draw the free body diagram of any piston, then you'll find there will be gravity force acting downward, pressure force acting upward, and the atmospheric pressure force acting downward. Since they are at the same level, then you'll find the pressure at the bottom, just below these pistons, will be identical. Outside pressure is the same. That means pressure force will be balanced by the gravitational force. Or we can say, since the pressures are identical, cross sections are S1 and S2, then we will say the gravity force divided by the cross sectional area for the two cases must be identical when this force was not acting. So we can write mg by S1 for this piston and alpha mg by S2 for this piston. So this is initial condition we can write, and if at all it will be needed, we will be using that. Now let's say on piston P this force F is applied gradually, and when this force is applied it becomes F, then you'll find let's say this came downwards by H dash, and the piston Q goes up by H, as the question says. So we can claim that whatever the volume it goes down, the same volume has to go up, considering the liquid is incompressible. So we can write it like S1 cross section into H prime must be equal to S2 cross section into H. Also, we will say when this came down by H dash, so the pressure at this point just below this piston is going to be same as the pressure at this level. Now you'll find that initially they were at the same level. So we can also think of that the amount by which the pressure changed in this left side will be same as the amount by which the pressure changed on the right side. So extra pressure came on the left side is F divided by S1. So this is extra pressure came in this left side just below the piston. On the right side, if you look at extra pressure is going to be the extra liquid that has been rising up. And the height now from this level is going to be H prime plus H. So it will be extra as rho g H plus H prime. So this excess pressure is equal to this excess pressure. Or if we write the total pressure, so we need to write these two terms both sides, so they will get cancelled out. Anyway, H prime can be borrowed from this. So H prime is equal to S2H divided by S1. So we can put this H prime over here. And from here we can take this H outside and balance this denominator. So S1 of this denominator will get cancelled out from here. So F turn out to be rho GH within bracket S1 plus S2. So this is the force that we have applied on the piston P, and this is the height which has gone by the piston Q up. Now, the question says, let's change this force, remove this force gradually first and then apply the force on the Q piston. And that force is beta F. So if the beta F is applied on this will be rising up. So let's say P rises up by capital H. If P rises up by capital H, then we can write exactly same equation again. And we will find that the equation will be like this. The force applied on one piston is going to be equal to rho g, the height rising by another side, into the sum of the cross-sectional areas. So that's written over here. So that turned out to be like a force which is beta f is equal to density of the liquid g and the height on the other side into cross-section s1 plus s2. Now using these two equations we can relate small h with the capital H. For that sake you can just divide the two. So if you divide the two, you'll find on the left side it will be 1 by beta, on the right side it will be small h by capital H. So from here capital H is going to be beta times h. That means the level of piston Q, that is the level of piston P that is going to rise when the force beta F applied on the piston Q is going to be equal to beta times h. Hence this will become our final response. Thank you.